Hi, math class. Welcome again to chapter 9, which today we're going to be talking about something called permutations. Okay? So maybe you've encountered this before in the real world where someone maybe on TV or they're talking about the possible outcomes. It's like they say, oh, there's like 17 million chances that this will happen, or there's like it's 1 out of 27,000, and you say to yourself, how on earth do they figure that out? And you might think to yourself, well, we've been doing some probability stuff, and I don't think I could use the probability factors that I do to find those big of numbers. And you're technically right. The probability that we've been working on is really suited for small numbers. But today, we're going to use a method of probability that allows us to work with really big numbers, which helps us especially when we get into scenarios with way, way larger options than like a dice cube or a coin, okay? And that's what a permutation is, okay? So, on page 766, sorry, I have to clean my glasses. What you probably need today, you probably will need something to write on. You probably will need a calculator, or you can use your calculator app, and you'll need your book open to page 766, okay? So let's go ahead and look at that together. What is a permutation? A permutation is an arrangement or listing of objects in which order is important. So what that means is, you see, for instance, there's a list of like some events: mowing, swimming, homework. That's 3 possible options, right? Well, we could actually find out how many different combinations we could do. So for some of you, in less than a year, you'll be looking at planning your classes for the high school that you're going to. And unlike in grade school, for some people, you'll have high schools where you have to kind of pick when's your math class, when's your social studies class, when's your English class, things like that. And so there's different combinations where you might take the exact same classes as your friend, but you take them at different times, so you don't see each other as much as you would like at school right now, because everyone's doing the same combination. And we're going to look today at how we could find the possible numbers of combinations of something like a class. And the way we use it is we use that fundamental counting principle. That's kind of the cool thing about the fundamental counting principle. It builds off of probability and allows us to do much more complicated things. So let's look on page 766 and look at number 1. Julia is scheduling her first 3 classes, so kind of like the scenario I was talking about. Her choices are math, science, and language arts. Use the fundamental counting principle to find the number of different ways Julia can schedule her first 3 classes. Okay, so we have 3 total options, right? We have 3 options because we have, make sure I get these right, we've got math, we've got science, and we've got language arts, right? So there's 3 total options. However, if I want to, for instance, let's say I pick math first. That's kind of nice, get it out of the way, right? And then I have what's left. Well, I have science and language arts left. That's 2 options. And then I say, you know what, I did some math. We're going to mix that up and have some language arts, right? And then, I'm going to say, okay, so then I only have science left, so that's 1 option. How many possible combinations could I do? 3 times 2 times 1 is 6. Because I could do like math, science, language arts, or math, language arts, science, or science, math, language arts, or science, language arts, math, or language arts, math, science, or language arts, science, math. 6 possible combinations of my classes in different orders. Okay? Hopefully that's making a little bit of sense. You take how many choices there are and just keep narrowing it down. So I had 3 choices, then 2 choices, then 1 choice. Multiply those across, and I get all my possible outcomes. Let's look at another example like that. Number 2, an ice cream shop has 31 flavors. Carlos wants to buy a 3-scooped cone with 3 different flavors. How many cones would he buy if the order of the flavors is important? Now, there's a couple different concepts or a couple different key phrases in this question that keeps us from having to do all 31 possible things, right? Notice what they say. 3 different flavors. So, we automatically know that there's going to be all 3 different possibilities in our cone, right? We also know how many numbers are we going to go up to? We're only going to do 3. Okay? I don't know if anybody's ever seen 31 pieces of ice cream, scoops of ice cream stacked on a cone. Not very stable. So, how many possible outcomes do we have for the first scoop? You're right, it's 31. So we have 31 flavors first. Then, how many then, if we pick one flavor, how many are we going to multiply by with the next scoop? If you said 30, you're right, because we've used one flavor, and that flavor's gone now, right? Okay, how many flavors then are it's possible for the next one? Well, it's the next one after 30, which is 29. So we're going to multiply 31 times 30 times 29. And if you do that on your calculator, you get 26,970. This is just kind of that fun little thing where if you, 26,970, that is a lot of combinations. And that's just with the 3 scoops, right? That's just with 3 scoops. Now imagine if we tried to find the combinations of getting a 31 scooped ice cream bowl, right? That'd be a lot. This is kind of those fun things with math where really, the numbers are endless. They go on and on and on, and you just continuously find new combinations. Let's see what you can do. Look down at A and B on page 766 and see what you can do. I'm going to go through them, but I want you to pause this video first, go through A and B, and see what answers you get, okay? Go ahead and pause the video. Hopefully you've done A and B, and so I'm going to do A first. In how many ways can the starting 6 players of a volleyball team stand in a row for a picture? How many am I starting off with? Well, it's 6 because it's 6 players. Now, what's next? Well, I'm going to multiply by 5. Then I'm going to multiply by 4, then 3, then 2, then 1. 6 times 5 times 4 times 3 times 2 times 1. I punch that into my calculator, and I get 720 volleyball players for letter A. 720 combinations, okay? So that's why, when you're lining up for a basketball or volleyball or soccer picture, you just do what the coach or the photographer tells you, because I don't think you guys have time to line up 720 different times, do ya? All right. Now, let's look at letter B. In a race with 7 runners, how many ways can the runners end up in first, second, and third? Now, here is the key part of this question. Am I going to go and multiply 7 to 1? No. Because how many possible outcomes am I looking for? I'm looking for 3. So, I go 7 times 6 times 5. 6 times 5 is 30, times 7 is 210 possible outcomes. Okay, so hopefully you got 720 for A and 210 for B. All right, let's go ahead and look up then at another way of talking about this when we look at the fundamental counting principle. We see the symbol P and then in parentheses 31 comma 3, close parentheses, represents the number of permutations of 31 things taken 3 at a time. So this is how we determine it's not talking about coordinate planes, right? We're not looking at an ordered pair. So that big P for the permutation tells us, okay, this is going to be a permutation. there's 31 possible outcomes. That means, and we're only going to look at the first 3. Okay? It tells me it's a permutation with 31 outcomes, and we're looking at the first 3. So we start with whatever number is right here in this coordinate. So we have 31. Then we're going to multiply it by 30. Then we're going to multiply it by 29. Okay? Multiply by 30, 31, 30, and then 29. So let's look at an example of this. We have a permutation that has, I minimized that, 8 with a 3 there. So we read this as saying it's a permutation with 8 probability outcomes, and we're looking at the first 3. How many possible outcomes are we going to get? So what do? Well, we go 8 times 7 times 6. We multiply that all together, and we get 336 possible outcomes. Okay? I'm going to do one more problem before I leave you guys to do some work. And I'm going to see if you guys can do it too, okay? So what happens if we have a probability of 5, and we're going to do 4. So P of 5 and 4. If you need to pause the video for a second, go ahead and pause and see if you can do it by yourself. If you want to do it along with me, just keep the video going, okay? So I go 5. There's 5 outcomes, and I'm going to do the first 4. So that means 5 times 4 times 3 times 2. 5 times 4 is 20, times 3 is 60, times 2 is 120 possible outcomes, okay? 120 possible outcomes. So, here's what I want you guys to do today. Below, in the comments, I'd like you to give me the answers to C, D, and E, okay? Below in the comments, give me the answers to C, D, and E. I hope you guys are finishing up those quizzes. Turn them into Google Classroom or send me an email with the answers when you're done. I hope to see you guys all again soon. Bye!